is lessons on solving two equations with two unknowns using elimination. So let's look at an example of two equations, two unknown, and see if we can figure out some strategies to eliminate one of the two variables. So here are our two equations. We have x plus y equals 4, and x plus 3y equals 10. So what we want to know is if any of these three strategies will eliminate a variable. So let's look at the first one. If we just add the first equation to the second equation, will that eliminate any of the variables? Well, if we add x to x, we'll get 2x. And if we add y to 3y, we'll get 4y. And if we add 4 to 10, we'll get 14. So by adding the two equations, we did not eliminate either x or y. We still have both x and y in the equation, and therefore this is not a good strategy for eliminating one of the variables. So let's try a different strategy. Let's try to subtract the bottom equation from the top equation. So if I subtract the bottom equation from the top equation, that's like putting a minus sign right there. So we get x minus x, gives us no x's. I won't even write that down. And then I'll get a y minus a 3y, which is a minus 2y. And then I'll get 4 minus 10, which will equal minus 6. So we see that by subtracting the bottom equation from the top equation, we've eliminated x in the equation. And therefore, using simple algebra one more step, we could actually solve for y. And it would turn out to be y is equal to 3. But that was not part of the question. So let's move on. How about this? Another strategy here. What if we multiply the top equation by minus 3 and then add the equations? That's a slightly more complicated strategy. It's 2 steps. So let's do that over here. We're going to multiply the top equation by minus 3. So this will become minus 3 times x. And this will become minus 3 times y. And this will become minus 3 times 4, which is minus 12. So that's the first step. And then add the equations. So now let's add the two equations together. So we'll get minus 3x plus x, which will give me minus 2x. And then we'll get minus 3y plus y, which will give me 0 y's, which I won't even write down. And then on this side, we'll get minus 12 plus 10 will give me minus 2. So now we can see that that was a successful strategy as well, because it eliminated the variable y. And so we could solve this equation directly for x by multiplying both sides by minus 1/2, and we would get that x is equal to 1. So let's look at another example and see if we can come up with some strategies for eliminating a variable. So let's look at another example. Suppose that in May, E Company used 1,200 microchips to make 100 cell phones and 200 tablets. Then in the month of June, E Company used 900 microchips to make 200 cell phones and 100 tablets. In July, the E Company plans on making 500 cell phones and no tablets. How many microchips are needed? So we're going to start out by writing a couple of equations and then solving for the number of chips we need. So let's start off by writing this. Let's look at that first line, and let's, this is going to be our solution over here. And for the first line, we want to have 100 cell phones. So I'm just going to call that 100C. And 200 tablets, so I'll call that plus 200T. And we use a total of 1,200 microchips. So I'll call that 1,200M over here. Okay. In the month of June, we had 200 cell phones and 100 tablets and 900 microchips. So continuing along, we can write this as 200C plus 100T is equal to 900M. So what we want to know is, if we make 500 cell phones, how many chips are we going to need? Well, the way we can figure that out is if we figure out the number of Cs, or the number of chips, microchips we use in the cell phones, then we can then take that number and multiply it by 500, and that'll tell us how many chips we need. So we know 100 of these plus 200 of those requires 1,200 of those, and 200 of these plus 100 of those equals 9 of those. So now we need a strategy that would eliminate the T's but keep the C's. So one strategy might be to take the second equation here and multiply it by -2, and then add it to the top equation. And by doing that, I can see that I'll get a -200 here and a 200 there, and they'll cancel. So let's do that. So let's use that as a strategy and write this bottom equation now. We're going to multiply it by -2, both the left and the right sides. And so I'll rewrite it here for clarity. We get -400C minus 200T is equal to minus 1800M. So this is our new equation. We can kind of get rid of this one. We don't need it anymore. And now, you see, if we add that equation to this equation, we'll get a third equation. We get 100 plus minus 400 is minus 300C. We'll get 200T minus 200T, so the T's will cancel out, so I won't write those down. And we're left with 1200M minus 1800M gives me minus 600 microchips. So now I can solve for C, and it's easy to see if I multiply both sides by 1/300 on this side, I'll get C. And on this side, I'll get 600 divided by 300, or minus 600 divided by minus 300, which will give me 2. So this says 2. So you see that each cell phone requires 2 microchips. So if we know that now we can answer the question. In July, the company will make 500 cell phones and no tablets. How many microchips are needed? Well, if we have 500C, right, and each C requires 2 microchips, we are going to need exactly 1,000 microchips. If we wanted to, we could solve this equation and come up with a strategy to eliminate the C's, or the cell phones, and see how many chips are required per tablet, right? And then use that to figure out, if we were going to make some tablets, how many more chips we would need to have on hand. So that solves the problem.